The next major thing that we're going to look at is something called trig identities. And in fact, it's sort of the main thing of this whole chapter. Trig identity is a statement that relates trig identities, and it's always true. So you actually, probably the most common one that you've learned already was one of our big ideas from chapter 6. Sine squared theta plus cos squared theta is equal to 1. And we've also learned from our previous chapter that the definition of cosecant is 1 over sine. The definition of secant is 1 over cos. Cotangent's 1 over tan. Tan is sine over cos, so that makes cotangent cos over sine. And all of these, because they're always true, means that they're identities. And so if you rearrange these ones as well, you could also write that sine of theta is 1 over cosecant of theta, that cos of theta is 1 over secant theta, and that cotangent of theta is 1 over tangent of theta. What a trig identity question looks like is as follows. And what we're going to do is we're going to do a couple of these that are on our paper together. So starting with question number 5, a trig identity question will look like this. It'll say prove, and then it will give you something, in this case, is cos of t times secant of t equals 1. And for proving identities, so this is an identity because apparently this is always true. There are some rules that we have to follow for proving identities. You want to prove that this is true. You don't know that it's true yet. So the way that we prove that it's true is the first important thing is we draw a line where the equal sign is, because you're not allowed to move something from one side of the equal sign to the other, because that is only allowed in mathematics if the statement is true. And we're trying to prove that it's true. We don't know that it's true yet. So drawing the line at the equal sign says we've made this a puzzle. We are allowed to simplify. We are allowed to use the mathematics that we know. And our goal is to try to get both sides of the equation the same. Right now, on the right-hand side, it's a 1. On the left-hand side, it's cos of t times secant of t. Now, in order to prove it, we're allowed to use the tools that we have. The tools that we have so far, and we will build on this, but most of the tools that we have so far are the reciprocal identities, the quotient identities. You know that tan is sine over cos, that cotangent's cos over sine, and we know that sine squared plus cos squared is equal to 1. And what you're allowed to do is you're allowed to look at an equation and say, can I change this to something? For example, what can I change secant to? That's one of my reciprocal identities. I know that secant is 1 over cos. So I can go to my equation and I can change secant to 1 over cos. Well, now I have cos, which I can make as a fraction, cos over 1 times 1 over cos. Is there anything that I can do for simplifying? Yes. Cos t divided by cos t would simplify, and it's just equal to 1. So we've completed the puzzle. We made the left-hand side equal the right-hand side. So first rule in solving identities is we rewrite the question and draw a line where the equal sign is. That line is so that you're not tempted to move one thing from one side of the equation to the other. After that, you simplify either one side or both sides until they are the same. In this case, we change secant to 1 over cos. Things simplified. It's simplified to 1, and now both sides are identical. So we write a statement that the left side is equal to the right side. Anybody know what these 3 dots mean? No, there's only 3. No, 3 dots. You know, yes, you're right. It means therefore. It doesn't mean there are 4. It just means therefore left side equals the right side. And, okay, now in a lot of mathematical proofs, after you say the left-hand side is equal to the right side, in a lot of math textbooks you will see this. You do not have to do this, but it's kind of fun. Okay? This is short form. Anybody guess what Q, E, and D stand for? I'll give you a hint. Each of the words is in Latin. Oh. Quod erat demonstratum. Something like that. That's probably really bad Latin. But it means what was asked for has been demonstrated. So we demonstrated what was asked for, that this was equal to this. Okay? And I add a personal touch after I do each of my proofs. I put a little square box and add some shading. If you want to create your own symbol, little smiley face at the end that you got it, because some of these proofs, when you get them, you will be quite happy. You've shown what has been asked for. So this is my own personal little thing to say that I've ended my proof. And the reason it comes from that, I think I had one math textbook somewhere that had this and had a little box. Sometimes when you read a magazine, an article keeps going from page to page with 17 pages of ads in between. And then a lot of magazines actually have a symbol for when they actually end the article. They have a little symbol at the end that says, the article's done now. You don't have to keep flipping and try to find the same thing. So I have a little box at the end. We're going to do a couple more together, and then I'm going to get you to try some. So we did number 5. We're going to do number 9 next. So number 9, it starts with cos y cosecant y equals cotangent y. So on your separate paper, we always rewrite the equation, and we start by drawing the line. And one of the things that you're going to start to notice, if you look at every single trig function that you know, cosecant, secant, cotangent, tangent, cotangent, every single one of them, there's a way to write it that's with sine or cosine. Like if you have cosecant, you could change it to 1 over sine. If you had secant, you could change it to 1 over cos. If you have cotangent, you could change it to 1 over tan, but you could also change it to cos over sine. So in this case, those green ones, they all change things to sine and cos. And the reason that's going to be helpful in our solving is if we want to have both sides the same, maybe it would be easier if everything was with cos and sine. We might get a little bit closer to having them the same. So for example, cos y I'm going to keep as cos y, but cosecant I'm going to change to 1 over sine. How do you multiply fractions? You multiply your numerators, you multiply your denominators. This side is cos y over sine y. With cotangent, I have a choice. I could change to 1 over tangent, or I could change to cos over sine. In this case, if I change it to cos over sine, my left side and my right side are identical. So we can write our statement. Therefore, the left side equals the right side. And we're able to prove it. So a lot of fraction work comes into play, because if you change things to sine and cos and you write both sides as a single fraction, most of the time your proof will be done. As we get into some of the more complicated ones, we'll have to do a little bit more, but most of the time your proof will be done. So I'll do one more that has a little bit more fraction work in it. We'll look at number 13. So number 13, tan u over sine u equals 1 over cos u. The right-hand side of my equation is already in cosine. It's already a single fraction. The left-hand side of my equation has tan and sine. I can change the tan to sine u over cos u. Some other logistical things that are going to help you with proofs, okay? A couple of things I tried to demonstrate here. Do you notice that I left a little bit of space right there? Because you are going to have fractions over fractions, and if you write things without a little bit of space, your brain is going to start mixing things up. So having neat and nice and a little bit of space in between your answers is going to be important. Next thing, notice that my main dividing line I made longer, because if you made them exactly the same length, is this sine u all divided by cos u over sine u, or is it sine u over cos u over sine u? It's hard to tell. So by making my main dividing line thicker, I can see what was on the numerator of my original fraction, what's in the denominator. How do you divide fractions? You multiply by the reciprocal. What is the fraction that I have on the bottom? I could write it as sine u over 1. So now a fraction divided by a fraction multiply by the reciprocal. I have a factor in common which can simplify. And now my left side is equal to my right side. So I can write my statement. And we're done.